Ladies and gentlemen, thank you for standing by. Welcome to the U.S. Department of Transport conference call. At this time, all participants are in listen-only mode. Later, we'll conduct a questions and answer session. Instructions will be given at that time. If you should require assistance during the call, please press *0. I'd now like to turn the conference over to the host, Jason Dieters. Please go ahead.
Thank you. Welcome, everybody, and thank you for joining us today. My name is Jason Dietz, and I'm with Federal Highway Resource Center and partnering with the Pavement Preservation and Recycling Alliance on a series of pavement preservation webinars focusing on pavement preservation by selecting preventative maintenance treatments so we can extend our life and reduce our long-term cost of pavement surfaces using AMA, ERA, and ITSA products and treatments. Today's webinar will focus on full depth recycling, or what we reference FDR. You'll see a number of polls on your screen. We ask that you take a moment to answer those as we close them in just a few minutes as the presentation begins. We also encourage questions during the webinar and ask you to please take the time to respond to the evaluations at the end of the webinar. All attendees are on mute, but you can submit any questions through the chat function on your screen, and we answer those as time permits. We will be offering PDHs for today's webinar upon request, so please let us know after the webinar if you would like to receive them. And as I mentioned in the chat already, you need to have your attendance list, your full name in there, so we can give you your PDHs. I'd now like to introduce today's speaker, Dan Shellhammer. Dan graduated from the University of Minnesota with a Bachelor of Science degree in Civil Engineering. Dan is a licensed professional engineer for the state of Minnesota. Dan is a member of Minnesota's Government Walls Sustainable Transportation Advisory Council, often referred to as STAC, and a member of the National Road Research Alliance Geotechnical and Intelligent Construction Technologies teams. He currently serves as a co-chairman of the FDR committee at the Asphalt Recycling and Reclaiming Association. When I asked about his hobbies are football and family are his hobbies. I'd like now to introduce Dan. And Dan, as for PPRA and myself for Federal Highway, I want to thank you for your time today, and we'll go ahead and pass it over to you. Thanks, Dan.
All right. Thanks, Jason. Excited to be able to get the opportunity to talk to everybody here today. Go ahead and get our presentation started. As we're shut down those polls. Yeah, so the topic of the day is full depth reclamation, most often referred to as FDR. Quick overview of what we're going to cover today. Through the course of our conversation on the webinar here, we are going to run through the FDR construction process. And when we talk about full depth reclamation, that's a pretty broad umbrella, and there are many things that are underneath the umbrella of FDR construction. So we're kind of talk about with different techniques you can utilize, especially with a modern reclaimer that you see pictured here. We're going to run through project selection criteria as it refers to the FDR process, and then we're going to discuss briefly some of the different stabilization additives that are available in the market today. We'll wrap up with the discussion on QC and best practices, and with that, we're going to start rolling here.
Hey, Dan, I apologize. Do you want to turn on your webcam?
Yes, I will. I think we're up and going. See myself, so there we go. All right, so why pavement recycling? Why are we here today? Well, FDR is in that pavement recycling category, right? There's many different tools in the pavement recycling toolbox, FDR being one of them. There's cold-in-place recycling, cold-central plant recycling, hot-in-place recycling, asphalt milling, and reclaiming. So all these pavement technologies, we're attempting to use fewer resources and recycle resources instead of bringing in, and they're all now at this point in their lives, they're engineered solutions that you can incorporate into your pavement network. And so selecting which one of those processes to use in your next project can be a pretty daunting task at times. And so that's why the PPRA, that's the Pavement Preservation and Recycling Alliance, put together a new website I want to make everybody aware of. It's called roadresource.org. This website is a phenomenal tool that gives information on all those recycling techniques I mentioned, and also all the pavement preservation treatments that are available in the marketplace today. Not only to give you information about those technologies, it also gives you guidance on where they're used best, what type of cost savings you can realize with them, and what type of energy savings you can realize when you utilize those technologies. So following the webinar day, I encourage everybody to just take a look at roadresource.org and use it as a great resource moving forward. So the recycling process, I know previously, ERA and the FHWA put out a webinar on cold and pitch recycling and cold central plant recycling, and that type of treatment is a partial depth treatment. Once you move into the FDR arena, that's a full depth treatment. So we're talking about taking care of typical depths of 5 to 12 inches. That material can either be pulverized in place, or we can enhance the properties of that layer by adding stabilizers to it. So places where FDR should be considered in your project selection process are when a road is shot and you've gotten to the point where reconstruction is something you're considering. In that type of scenario, that's when you should probably be having a conversation and looking to see if FDR in lieu of a total reconstruct might be a good option for you. So throughout the presentation today, we're going to be doing some poll questions for folks just to see where people are at in their recycling knowledge. So the first poll question, number one, is in-place asphalt pavement recycling to reduce construction greenhouse gases as compared to conventional mill and overlay strategies by. We'll give folks just a second to see what your perceptions of that are. Yeah, we're seeing some interesting numbers coming in here. The answer is more than 50%. So when you utilize that tool in the right place and the right job, it can be really beneficial when you're looking at sustainability and project performance there. So speaking of sustainability, that's one of the things that we're looking at here on our projects. Here we go. When you utilize the right pavement recycling technique on the right job, you're going to realize those substantial CO2 savings. It's going to be very impactful to the sustainability overall of the job, because we're recycling, we're using materials in place that are already there. Right? We're eliminating many, many loads of materials coming to and from a project, and it can be really impactful when you look at the process from a sustainability perspective. One of the mantras you'll hear about from ERA, from our association, is utilizing the right tool in the right place in the right time. So there are many different asphalt recycling strategies that one can use on projects. The secret to the sauce is utilizing the right tool on the right job at the right time. Once you do that, get the right tool on the right job at the right time, you're going to save money versus a conventional construction technique. You're also going to save time. If you're using the right tool, you should accelerate your construction process. By utilizing and recycling that material you already have in place, you're resetting the pavement design process, and in effect will then extend the life of your pavement. And once you do that, you reduce your maintenance costs. And then we're also going to have the added benefit of being more sustainable in the way we approach our designs, right, by reducing carbon emissions and recycling reusing materials. So keep in mind as we have our conversation today, that when you use the right tool, the right time, the right place, project selection is key. You don't want to jam square peg in a round hole. Because if you do the wrong recycling technique on the wrong job at the wrong time, it'll end up costing you more money, and they won't be able to realize any of those economic or sustainability gains. All right, poll question number 2. The cost of in-place recycling can be blank the cost of conventional reconstruction strategies. See what folks out there think. All right. The answer is 40 to 60%. So some good guesses out there from folks. Thanks for participating in the poll. As I kind of alluded to earlier, full depth reclamation, that construction technique, we like to refer to it as the multi-tool of pavement rehabilitation. There are many different applications in construction where you can use a modern reclaimer. And the 4 that we're going to focus on today that are probably the most popular underneath that FDR umbrella, number 1 is asphalt pulverization. 2 is soil drying or modification of materials in place. Incorporating liquid additives to stabilize a layer. Incorporating dry additives to stabilize a layer. So in the asphalt pulverization process, we're going to bring out a modern reclaimer. And that reclaimer is going to use a high-speed upcutting drum to pulverize the full depth of in situ asphalt. The end result is going to be a recycled blended material that you can use as an ag base for your roadway project, or even add stabilization additives to it to gain structure for your roadway. There's a lot of science and technology that are working behind the scenes for the performance of a modern reclaimer. You can see here the process starts with that reclaimer, and once you conceptualize the way a reclaimer works, it's very similar to a garden tiller. It's instead of being 9 inches wide, it's 8 feet wide and has 800 horsepower behind it. Right? So it's a very powerful machine. And the way that it works, we have the direction of travel here going from the right side of the slide to the left. That would be the way that a reclaimer travels. And that upcutting drum, the way it works is initially those teeth, as they come around, they come down to the aggregate base down below that asphalt layer. That aggregate base actually cools our teeth. It helps prolong the life of any metal wear parts that we have there. So it's important to get below that asphalt layer as we're pulverizing that material. Then tooth then comes in contact with the bottom of that asphalt layer, rips its way up and through that HMA, and comes back around and takes another bite of it. Once that material is free of that asphalt layer, it is in the housing and being crashed and banged around. There are impact plates and breaker bars that are around that housing. With the arrow here, you can kind of see that. So this would be a breaker bar. There are generally some impact plates that can be located around the housing as well. So as that material is getting thrown around the drum, there's a secondary crushing operation that's happening with that velocity. So once it hits those types of areas around the housing, it's a secondary crushing operation that's happening. And so as we're working our way on down the grade, the end result is a nice blended base. What you generally see on an asphalt pulverization project would be a reclaimer out in front, pulverizing and sizing that material, followed by a roller, generally a pad foot roller, because we're doing a deeper type of recycling process, 5 to 12 inches, and a blade will follow behind that to smooth that material back down, and then we'll finish roll it with a roller. I would say just something for folks to keep in their minds, just to know about a modern reclaimer. It does have hydraulic doors on both the front and rear side of that housing. The hydraulic doors are there for access for maintenance items, for putting in new teeth, do welding on the drum, doing both types of activities. And then when they're closed down and in that operation mode, that rear door here can sometimes act like a screed. What does a screed want to do? A screed wants to push big chunks down and fines to the surface. So a best practice when you're doing asphalt pulverization is to always dig down below the surface and see what type of gradation you're getting. So you can see from the picture here, it looks very fine and smooth graded material. If you dig down, there's a probability you might find some chunks if an operator is going too fast. So you always need to dig down and investigate behind the reclaimer.
Hey, Dan, I apologize for interrupting you.
Yep.
Maria, I apologize. I think everybody's just seeing the first slide. It hasn't advanced. Is that correct? Can I get a show of hands that people are just seeing the first slide?
Okay, let me try this here.
Thank you, everybody.
Dan? Yeah, can you try advancing again? You should see the first slide now. There we go.
Yeah, just advance the slide too.
Yeah, Dan, feel free to use the arrows to advance, okay?
Yep, that's what I'm doing.
Technical glitch, we're back on. Sorry for those that we didn't jump on that sooner. Okay, Dan.
Okay. So I talked about the rotation of the drum that you'll see there, that cutting drum and the material that it produces. And so we're trying to produce a blended base, create an aggregate base, recycled aggregate base that we can reuse then. So you see here, you get an idea of what the FDR mats, an asphalt pulverized mats, might look like. And as you're working on different types of materials, different types of aggregate bases, it can change in color depending on what type of aggregate was used as an egg base, or if maybe some roads have been paved on top of just clay or silt. We can end up with some chunkier material, but really it's the combination of blended materials from what you're recycling. And generally, I talk about having to get underneath that asphalt layer. We need to be a minimum of 1 inch below that asphalt layer to cool the teeth of that in the housing for that reclaimer. So another item of work you can do in the FDR process is soil drying or modification. So what we're going to be doing in this type of situation is you'll have a project where the grade is over optimum and it needs to be dried down quickly. Generally, the way the folks are doing that today would be you might farm it, that material, right, disc it up and let nature try and air it out as much as possible, or you might do a removal and replace with drier material. So with the FDR process, you actually have a third option, and that is to modify that soil, that over optimum soil, with a dry additive. It could be cement, it could be lime, it could be something else. It's a great application of FDR. And so what are we going to do for that process? We're going to bring out another piece of equipment. It's a vein spreader. That vein spreader is pictured here below. That is going to broadcast a dry additive on the ground. See that here. That material is then going to be blended with in situ materials with a reclaimer. As we work our way on down the grade, depending on how wet it is, we may or may not want to initially roll that material. You might need to give that additive some time to dry before you want to shape it, but then it'll be graded and finished rolled. And again, in this type of scenario, when we talk about soil drying and modification, it's not an engineered solution. All we're trying to do is dry down that material to a point where we can pass a roll test to work with yielding with any type of loading you put on top of it. And another option you have underneath the FDR umbrella is liquid additive stabilization. blending in situ materials with liquid stabilization additives to improve the performance of the engineered stabilized layer. So in this type of scenario, we're going to be able to enhance the material properties with the existing materials we have on site by adding the liquid stabilizer. So through this process, what we're going to do is bring out a load of liquid material. It could be in emulsion, foam, calcium chloride, magnesium chloride. We'll talk about that a little bit more later. But that material is actually going to be injected into the housing of the reclaimer and then blended with that base in place. And as that process is going on, there's a lot of technology at work there. So on board a new modern reclaimer is a calibrated injection pump that's tied to an onboard computer. An onboard computer knows the speed of the reclaimer and also the depth the reclaimer is cutting, and it takes care of injecting the precise amount of liquid into that stabilized base. After that material is blended, it will be rolled, then bladed, and then finish rolled. You can see here another cross-section of a reclaimer. So the housing itself here is similar to the other picture we showed earlier for some of you folks. We have the direction of travel here. We have our upcutting drum, and this is the inline injection system for a reclaimer, right? Some reclaimers you can inject 2 types of liquids at a time. Some only have one, some have none, right? So it just depends on what the contractor, what type of package they put on the reclaimer, but in order to do it efficiently in the right way, injecting it through that onboard system with an injection pump and having the computer ready to go and calibrate is definitely the way to go. And then we have dry additive stabilization. So similar thought process of this, liquid stabilization, just the additive is dry instead of liquid, right? We want to engineer or improve the structural capacity of that layer so that we don't have to import additional rock or make some other choices as far as pavement design goes that are at expense to our project. So we're to make our in situ materials perform better by adding dry additives. And the way we do that is with, I talked about earlier, but that modern vein spreader. And so that modern vein spreader is actually good. It has a vein in the back of the truck here that controls the distribution of that powder. The speed of that vein is controlled by an onboard computer, and that onboard computer knows the speed of the truck and where it is in the world at all times, so it can very accurately distribute that additive on the ground. So these modern construction technologies are what has made the FDR process much more repeatable versus maybe some experiences folks had 20, 30 years ago. And so when we're in the dry additive stabilization, when we're doing that process, we're adding a step, right, with the spreading of that material on the ground. And then generally what happens is because we're adding this dry additive, it's going to absorb the in situ moisture that's in our stabilized layer. So we need to compensate for that so that we can get good density out behind the reclaimer. We compensate for that by adding water with a water tanker. So we hook up that water tanker to a reclaimer just like we would on a liquid stabilization project. We're using the same technology, that injection pump and onboard computer, to get a precise amount of water incorporated into the blended mix that comes out the back of the reclaimer. The reclaimer, after it's blended that material, it will then have a roller out there that'll roll that material. We'll blade it out and then finish compact that as well. And so really optimizing the amount of water that we add to that mix is key in ensuring that we get good density out behind us in a consistent, stabilized layer we can count on for years and years. So the front of the train, the FDR train, with all that technology that's going on there with the modern reclaimer, the modern vein spreader, that's generally where folks like to focus because that's new and amazing and great technology. But the back end is just as important. It's critical to have your compaction and blading fleet, compaction and layback fleet, working in concert with the group up front. So the initial compaction needs to happen with a large pad foot roller because we're stabilizing depths at 5 to 12 inches. And once we do that, one question, are separate pulverization and mixing passes necessary? This would take a little breakdown. In our experience, yes, they are. They're generally necessary because once you add an additive, you can't go through and reblend that material. So our preference would be to do an initial pulverization pass and appropriately size that asphalt, and then add the stabilization on a secondary pass. But getting back to initial compaction, you're going to want to use a large pad foot roller for that deep section, and the pad foot roller is going to need to walk back and forth until you start seeing the underside of that drum. You start seeing the pads lift the drum up out of the ground, then you know you have density. It's just a great field observation to make. Nuclear density gauge can tell you the same thing. That observation is great. And then a best practice is to keep that pad foot roller within 75 feet of the back of the reclaimer at all times. So that material coming out of the back of the reclaimer is going to be right at optimal moisture. That's right when we want to start a compaction. Right, we want to get that material as dense as we possibly can. So by keeping that pad foot roller up near the back of the reclaimer ensures that we're going to be compacting that material at optimum moisture. Then having a back drain blade on a pad foot roller helps out with production a bunch. That's just a better practice, I would call it, not a best practice. It really reduces the work that a blade operator needs to do. So after we've done our initial lay down, or the initial compaction, we're going to lay that material back. Generally, in the industry, this is done with a motor grader. Some folks do it with a dozer. Any type of blade will work on a smaller scale project, even a skid steer. A skid steer with a good operator can accomplish this as well. They wouldn't be able to keep up with high production, but it can work. I've seen it work. And what we're going to want to do is we're going to want to initially blade up down to the bottom of the pad marks from that pad foot roller. So basically the bottom 3 to 12 inches of that layer has been compacted. We then need to get those pad marks filled back in and reblade it, and do some final compaction to get the top 0 to 3 inches compacted. And so best practice with the blade, you want to get to the bottom of those pad marks. You always want to maintain the width of the roadway. So you always say this, an experienced blade operator is worth their weight in gold, especially in today's skills market. If you have an operator that's not experienced, they'll end up trying to waste some of that material into the ditch. What that's going to do is actually going to skinny up your stabilized layer thickness, and you need to keep that material up on top of the road top, right? So you don't want to be wasting that material down the ditch. You want to keep it up on top and reestablish that cross slope and profile of the road. And you need to keep up with the reclaimer, and don't never lag more than an hour and a half behind that reclaimer. Your blading work. Then you want to form your final compaction on that top, 0 to 3 inches of depth. The pass count will be established, by rolling pattern. You want to be checking the moisture contents, make sure you're still within the optimal mix design back there as well. And then you want to finish that final rolling pass within 2 hours of the blending of the material. So we really don't want to mess with exceeding that 2-hour limit, because that's when your stabilization additives are starting to form their bonds. They're starting to cure themselves out, right, and grab onto particles to hold everything together and give you that structure. If you're on it past 2 hours, you break some initial sets and you won't realize the full potential you have for really strengthening that layer. All right, so walk through kind of those 4 construction processes underneath that FDR umbrella: asphalt pulverization, soil mixing or modification, liquid stabilization, and dry additive stabilization. And all those have the right time that they should be used, and the right payment condition, with the right in situ material composition. And so another subset of that is then you have to use the right tool, the right time, the right place when you get to additive selection. All right, and there's many different types of additives available in the market today. I just kind of tried to list some of the more prevalent ones that are available. So On the dry side of things, the powder side of things, you'll have cement types 1 and 2. Just your regular run-of-the-mill cement works really well for stabilizing. It's not near as efficient as lime could be for drying, though. Lime is a great drying agent that can be either quick lime or hydrated lime. Lime also in the right conditions in soil with a high enough PI can also be a stabilizer as well, a really efficient, cheap stabilizer. We've used bentonite in the past for pond liners, not so much of a roadway application, but I want to just point out that the FTR process is really flexible. It can be used in lots of different places. And there's some byproducts that are available. It might save some folks some dollars. And those are, cement kiln dust, lime kiln dust, and fly ash. All those at varying degrees of availability. Some regions are easy to get a hold of, some they're not. Fly ash is the one that's kind of really hard to get a handle on, especially because the climate's changing really quickly. So most power plants are switching from coal as their fuel to natural gas, which is making fly ash for stabilization groups harder and harder to come by. Most of the fly ash we're seeing is getting consumed by ready-mix companies. So that's a regional cause and effect, I would say, depending on where you're at. The mineral consolidators, those are things that help kind of realign the existing particles and give you some extra structure, or might be able to help you dry some things out. On the liquid side, we have emulsions. Most folks have moved to using engineered emulsions at this point. Not too many people are still using CSS1 or high soap. There's PG-graded binders that you can foam, that hot oil you foam. Incorporate that into your asphalt pulverized base. Calcium chloride, magnesium chloride, base one enzymes. These have all been used as well in that type of application. Generally, those are used on lower volume roads, gravel roads. We've seen calcium chloride be used really successfully on projects on gravel roads where you maybe have to blade that road every 2 to 3 weeks because of washboarding. If you inject calcium chloride and blend it in that top 4 inches, you can reset your blading efforts. Instead of having to blade every 2 to 3 weeks, it could stretch out to 6 to 8 weeks, which can really help a county or a city out that has that type of application. And then with all these different additives, they all have their different price points, and they all have their different soils and materials that they work best in. And so you really need to optimize the use of those on your project with the material that you have in place. So after we've completed our construction process, for dry additives and liquid additives, the curing process is a little bit different. So for dry additives, they're going to want to pull moisture in. They need that moisture to gain their strength for the chemical reaction to happen. So in doing that, we need to make sure we're keeping it wet. And so we'll need to either water down from the top, those types of stabilized layers, or cover it up with like a light fog seal to prevent that moisture from escaping. And we'll see those cure times. They're dependent on weather conditions, but they're usually in 24 to 48 hours. A great tool to have on a stabilization project is DCP. They're really cheap, and they prove out, and you can see a lot of repeatable results using a DCP. So you use a DCP to watch the strength gain of that stabilized layer. You know when you can get traffic on it, or when you can load up your trucks or other things. It's a really good tool. Then just if you do need to get on a stabilized layer early, just a better practice would be to end dump that gravel on the stabilized layer and push it out. Don't run loaded trucks over the top of it when it's still fresh and new. And another, I guess, a safety item to be aware of if you're stabilizing clay. At times after a rain event on clay that's been stabilized, those clay fines can get a little bit wet, the top gets greasy, and can be a little bit slippery. So if you're on traffic on something like that, you're going to want to dirty that surface up with some aggregate or something else. Just something to be aware of. And the liquid additives, so that it's the exact opposite. We're not trying to keep the moisture in, we're trying to get the moisture out. And generally that curing time takes longer, 3 to 8 days depending on weather conditions. But during that curing period on liquid additives, the surface is generally more forgiving. So you can get traffic on it a little bit sooner without causing some problems. And a DCP is a great tool to use when you're analyzing the strength of that material. what do we surface this FDR stuff with? Well, it has to be surfaced with something, right? They have higher voids than voids in HMA, right? So they're susceptible to water infiltrating that stabilized layer. So you need to cover them up and protect them. And there's a lot of different options that are available to folks. Those decisions generally come down to economics and traffic volume. So we see just one lift of HMA being placed on some projects. Sometimes it's multiple lifts. Sometimes it's fog seals, cape seals, chip seals, or any other type of pavement preservation treatment. And if you're curious about what the types of treatments are out there, you can check out roadresource.org and get some more information about the options that are available to you. All right, so a chance for a poll question here. Here's to see on your last recycling project, the surface placed on top was yeah, it looks like most folks are going with some HMA, either in a single lift or multiple lift. That's interesting. So just want to point out, FDR has a multitude of applications. It can be used and is used everywhere, every day in the road building industry. So in the picture here, you can see there's 4 reclaimers working in tandem here, pulverizing an airport runway. Right? It's a great way to recycle that hold up asphalt in place. And so the FDR applications, and they're being utilized on the interstate, at airports, state highways, in urban environments or rural environments. Downtown Minneapolis here, I'm talking to you from Minnesota today. It's happening downtown, and it's being used in conjunction also with composite pavements and right up next to curb and gutter. So it is a very versatile tool that can help you out a bunch. Now, kind of summarize the FDR construction process. Let's talk about planning a job. What are we looking for? I really do like this picture here because it shows an old tired roadway, right? What types of distresses are we seeing here? Well, I can see some wheel path rutting. I can see probably multiple attempts to do some crack sealing. There's longitudinal cracks, transverse cracks. Some spray patching has gone on. Some more in-depth pothole patching has happened. The asphalt that's there is oxidized and shot. And so really, you don't have many options left this road. You're kind of down to that point of needing to reconstruct it. So, well, you should really consider doing FDR. This type of road would be a great candidate for FDR. And some things that FDR can address, right? Some problems that it'll fix for you. It'll take care of all those cracks and ruts, right? Because we're going to remove that asphalt. Not remove it, we're going to recycle it in place by pulverizing it. So that's going to reset that crack pattern and get rid of all those ruts. Through that process, right, we're going to need to overlay it with something, so that's going to take care of your ride quality issues. If you have a road where you're seeing raveling, potholes, bleeding, you have some old oxidized asphalt that's just not holding together anymore, we're going to repurpose it. We're going to give it new life through the FDR process. And we can definitely take care of if you're having shoulder drop-off issues on a job, because we are recycling that material in place. We are going to be able to spread the pulverized material back out and reestablish the shoulder and the cross-up and build those back up. And then if you do have inadequate structural capacity or subgrade issues, we can stabilize that material, shore it back up, strengthen it, and get it to perform in a way that meets our needs. So in the pavement planning process here, the first thing we're going to need to do when we're analyzing a job needs FDR is to perform an accurate pavement assessment. This is really going to be done on any project. What does this all entail? We're going to take some cores and pay specific attention to those cores as they come up out of the core hole. and document, the condition of those cores and really what's going on there. GPR, ground penetrating radar, is a great tool to know how uniform your asphalt thickness is. We need to understand the type of traffic counts that roadway has experienced to date and what type of traffic counts you'll have in the future when we're going through our engineering design. We're going to want to look at drainage. Water can kill a road. It does often, right? So we have to ensure the water's getting away from our pavement. And then we have to look at that subgrade. Is it strong enough? Is it stout enough? Do we need to stabilize it? Do we need to enhance it? Or is it good enough to just pulverize that material? And we always want to look at construction records and see how many lifts of chip seal do we have on there? Is there any paving fabric in that stabilized layer or even in the HMA? And just so folks know, reclaiming paving fabric for our company has never been an issue. We generally tear that material up very efficiently and quickly. The only issue you might have would be when you look behind the reclaimer at that pulverized material, we're pulverizing paving fabric. We can get that material down to maybe 3-inch by 4-inch max sizing. Generally it shreds up a lot better than that, but you might see a tail flipping up in the air in the back of the material behind you, but we can't remove it. But we can definitely size it down where it won't have ill effects for that pavement structure. And we also want to look at old asphalt mix designs. So when you're deciding if you want to do just a straight pulverization project versus maybe having to stabilize it, a lot of that might have to do with the composition of the old hot mix. If that hot mix was made out of great fractured rock, right, then you probably can get away with just a pulverization job. If that old HMA was made out of river rock, right, that's rounded, it doesn't give you very much structural integrity, that's really only holding it together is the oil, that might be a case where you need to look at doing some things like stabilization. When you're pre-planning, there's some new technology and some new tools out there that are really, really helpful. FWD, falling weight deflectometer, that's going to tell you what the strength of your road is. It'll help identify where any weak spots in the road might be. It's a great tool. GPR as well, I kind of said already. And then coring, I'm just going to tell you how deep those materials are. So to get you materials for doing a mix design, and dropping a DCP in the core hole is a really great practice. Just because you're looking at how structurally, what are we looking at there? And we want to encourage everybody to make that small upfront investment in that pre-planning phase to do this accurate pavement assessment. It's a cheap insurance policy that'll prevent you from having a large change order out in the grade during construction. It can identify a lot of problems that are out there. I just want to give an example of that, the power of coupling both GPR data and FWD data together on top of each other. So we did a job in South Dakota with a county there, the highway soup, and they wanted to do 8 miles of cold-in-place recycling on this project. And the county highway soup had not been in this position very long, didn't really know the history of the road that we were going to potentially recycle. And so we encouraged them to go through and do an accurate pavement assessment. And as we went through and did that on this 8-mile section of road, we were able to identify with some really good accuracy areas where he had deficiencies, where he didn't have enough structure to hold up the traffic loading that he was anticipating. All right, and so we were able to then change our plan. Instead of doing CIR on the full 8 miles, what we did was in these isolated locations, we did FDR. We fixed those spots with insufficient structural capacity. I incorporated 12 inches of stabilized material with cement. So on an 8-mile job, about 7.5 miles got cold-in-place recycled, and the other half mile we performed cement stabilization. And it worked out really well. There were no change orders on the job. There were no soft spots, dig outs, anything else. And we never would have identified those ahead of time if it weren't for that project planning that happened up front. So mixed designs are a great tool, right, to optimize the amount of stabilization additive we're putting into the road. And that's the goal of a mixed design, is to optimize performance of that stabilized layer. There are many different examples out there of what a mixed design process can be, specifications and other things. We're not going to go over all that today, but the outcome of a mixed design would be to optimize the additive incorporation rate and then communicate to the contractor how much that material needs to get into stabilized layer. Generally, it's communicated to folks in pounds of dry additive per square yard or gallons of liquid additive per cubic foot. But that's what the mixed design process is for in a stabilized type of configuration. And just best practices, for that pavement sampling for mixed design, we're going to need a lot of material, about 400 pounds. And what you're going to do is, if there are multiple lanes, you want to vary our sampling across those lanes. You definitely want to vary the location of your samples across the width of the lane as well. Include shoulder material. And then always, when you're pulling the core out, make some visual observations at the bottom of it stripped out, and collect some of that stripped material or not to include, to communicate to the lab, and what does that base or subgrade look like down below. Then the mixed design process, got some pictures here of just some of that equipment you'd see in the lab. We're definitely going to do a proctor, and it'd be pretty dangerous with a proctor. It's going to give us a soil identification or know where the optimal moisture is at, the weight of the material, which will help us out with our additives. The mixed design process, we will be able to see how varying that additive in our mix changes the characteristics. Are we strong enough, not strong enough? How does that help? And develop a curve. We're also going to do some durability analysis if we want to. All right, we can run that material through freeze-thaw scenarios. We can run that material through the Hamburg wheel, look for rutting potential, especially if you're looking for that stabilized layer to perform at a higher mark. You're going to want to run it through some of that durability analysis. And then we're looking for, being able to communicate the pavement design characteristics that the engineer is looking for. We have a poll question here, poll question number 4. My agency has used the following treatments on our pavement network. It looks like FDR is winning the day there. Good. There are many applications for FDR out there in the world. So now I want to hit on just kind of the quality control process and some best practices that are available today. Really, a great quality control program starts out with a rock-solid project specification and knowing what your quantities are, right? So that we can communicate to the team that's building your job just what your expectations are and what your needs are. So it's important to have accurate construction plans, accurate quantities, and then explain to the contractor what your mixed design requirements are. Some entities will do that mixed design themselves, right, pre-letting, and communicate that information to the contractor. Some owners will have the contractor do that mixed design for them, and have them be responsible, right, for developing that plan, right? And all they'll do is they'll tell you how the mixed design how it should be performed, how it should be analyzed, the threshold that stabilized layer needs to get up to, and they tell the contractor, hey, you go optimize it. So there's lots of different ways to do that. In that project spec, you also want to have your quality control plan laid out. And I think a great tool that folks, if it's your first time utilizing the FDR process, or maybe any pavement preservation or recycling process, is just-in-time training. So The idea behind that is generally about a week or so before that FDR construction process is going to start. The contractor will bring out an industry expert to educate everybody that's on the project team about the process, right? Any project manager, anybody doing QC, QA out in the field there is going to get some training on just what to expect with the FDR process, how it works, what to look for. I think it really helps create a much better final product, right, and gets everybody on the same page with where a job can start. All right, the quality control, right, everybody trusts the contractors that are working for them, right? But what we need to do is trust but verify what they're doing out there. So in an FDR full depth reclamation scenario, what are we trying to keep track of? What material properties are important? Keep an eye on. Well, number one is the gradation. Whether you're pulverizing or stabilizing, that gradation information needs to be within specification. You're going to want to do depth checks. Right? You want to verify that the stabilized layer is the depth that we want it to be, or that we're recycling the full depth of asphalt and getting down where we want to be. Moisture and density, those two work together. Right? We need that information. It has to be communicated in real time to the construction team so that we get that optimal density and get compaction. The DCPs, we love using DCP because it gives us a lot of great feedback, real-time feedback, and it's pretty easy to use. So those are the material properties that we're looking at, and then and the tools we're going to want to use, the additives. There's some things we're going to do when we're in the stabilization mode. We're going to want to be doing calibration checks to make sure that modern equipment we're using is yielding up correctly. And as always, you're going to want to summarize the road tickets. So if you're going to have a QC person that's out there doing their job, they're going to be establishing a rolling pattern and identifying that target density either through a growth curve or a proctor. If you're doing a growth curve, that might need to be done several times a day, sometimes just once a day. But if you're going through varying materials, you're going to need to stay on top of that. That's done most easily with the nuclear density gauge. We're going to want to be comparing field gradations to mixed design gradations. So if those gradations are similar, then our stabilization additive incorporation rate will be spot on. If those field gradations start to differ, then we may need to reprocess some asphalt, repulverize it. We also might need to look at the materials. Did they change? Did the in-situ conditions change? We didn't catch it in the coring phase. We haven't identified it. We have some new stuff out there. We need to get together as a project team, analyze that, and come up with a working process moving forward by comparing those gradations. We want to look at material yields, and then after construction, we're going to want to monitor moisture content. Moisture content is going to indicate when we can surface that material. And always enforce specifications and allow input from the contractors. And encourage input from both the QC personnel and the contractor. I always like this picture. It kind of encapsulates what's going on a dry additive stabilization project, right? We have that reclaimer that's blending the material, pulling water out of a water truck, injecting it into the housing. There's the dry additives on the ground. It's already been broadcast. I put rollers right behind that reclaimer. The blade is there working that material right in concert with what's going on with the smooth drum roller behind. And then you have a QC technician out there, right, working their butt off and doing their job. I'd say one of the things that QC technicians are going to want to do is throughout the course of the day, check moistures out in front of the reclaimer, and then check the moistures of the material that we're stabilizing and producing in the back. Right, so that moisture in front of the reclaimer will be communicated to the operator of the reclaimer, and then we'll figure out how much water needs to be added. And if that injection system is working right, and we're adding the right amount of water, then we'll be right at optimal moisture behind that reclaimer. So it's important to have that QC technician work in concert with the contractor there to ensure you have a great stabilized product. Then the poll question number 5 for folks wondering what are the challenges to setting up an FDR project for my agency? What might they include? All right, we're seeing some varying responses here. At the end of the presentation, kind of Jason's prompting here, there's a bunch of resources that should help everybody out with all these things that you see listed there, folks. So there are some things to pay attention to when you're doing FDR, and that's the weather. The weather will affect the final product that you're producing. All right, so, and the weather window for different stabilizers can change, right? Generally, if we're injecting some oil, we want to have that temperature be 50 degrees or above. Once it gets below 50 degrees, you might start seeing some rattling and some issues with densities. If we have freezing temperatures, we do not want to be adding cement because those frozen temperatures will flash that hydration process and it'll just stop, and then you're not going to get the results you're looking for. So understanding when the work will be going on, what type of work is going on, and how temperature and weather can influence that stabilization additive is critical. Picking the right tool at the right time, the right place. Just want to run through some best practices, some different ideas that are out there, show you kind of what's in that best practice vault. What are the keys for ensuring you have a successful recycling project? Number 1 is project selection. So the construction community has gotten together and really worked on getting equipment out there that can provide you with repeatable results, right? By putting into place engineered controls through that equipment. So now that that issue is no longer a problem with the FDR process, really project selection, getting the right tool on the right job at the right time becomes critical. And if you're going to do that, you want to utilize all those engineering advancements that we have made, right? You want to do FWD, you want to do GPR, you want to utilize the information that you get through the mix design process. All that technology is involved in the quality control process as well, right? Use all those tools that are at your disposal. And then always ensure you're utilizing modern, construction technology on a project. And yeah, that'll ensure you go from having a patchwork project to a great completed product. There is some concern, or it might even be just discussion points. These aren't necessarily go, no-go for FDR, but they're things that you really need to account for, the things we really want to watch out for. So one is widespread subgrade failures. If you have that going on, you really need to find out what the source of those issues are. The FDR process can overcome many of them. The ones that it struggles to are probably what any roadway project struggles with would be water, right? If you have a roadway that has multiple springs underneath it and it's really wet, you're going to need to address that. The FDR process can't fix that. If you have a lot of frost boils, the FDR process can help with that initially, but if you put stabilized materials over a frost boil, it won't last near as long as you anticipate it will because of those forces in nature with water pushing up and down. So water's our enemy. We have this picture here. So this is actually a drill pad we did up in North Dakota. We stabilized some blue clay up there. It's some pretty nasty stuff for their 250,000-pound drill rigs. And that process works really well until you have a water issue, right? So you can see there that that stabilized layer stayed intact and actually held up under its own weight. But if you have water washing away that surface below, it's not going to live a very long life. So other areas of concern are variable materials. So this happens on about every project. Not every project, but on some projects, where that material, if you're working in subgrade, might go from being a silt to a clay to a sand, or a combination of those things back and forth, right? So when you look at your stabilization additives, some of them work in a really wide band of materials. Some of them work best in a very narrow band of materials. So if you have a wide band of materials, you have to match up your stabilization additive with what you have out there in the field. So just something to be conscious of. That's why we talked about utilizing the right tool, right time, the right place. That goes not only for the construction process, but for the stabilizer you're using as well. Some safety components to talk about here with the FDR process. So traffic safety is number one, right? That's something that's always going to be a concern. This equipment that we're talking about, it is bigger than like a 950 cat loader, and they're heavy. And it's kind of lull you into complacency in that they don't always move real fast, but it can be kind of dangerous. So, in the traveling public, the roads getting busier and busier. Traffic safety is very important. Extremely hot oil if you're running through the foam process. So that oil is going to be 310 to 325 degrees Fahrenheit. We have a mobile platform that's working its way on down the road. You really need to be conscious of what you got going on when you're foaming jobs with a mobile platform like that, and really respect that hot oil. You want to respect the equipment too. It kind of alluded to this, but it's the size and speed of that equipment. There are cameras on those, backup alarms, mirrors, all types of things to help see around that equipment. But best practice would be always making eye contact with that operator when you're working on equipment. That's dust if you're doing dry additive stabilization. If you have a day where the wind picks up, right, it's exceeding 15 to 20 miles an hour, that might be a day where you can't stabilize. You can't do your FDR process because that material will pick up and blow away, right? So you need to reduce the effects of those by keeping an eye on the weather. And then always have a spill plan, right? Whether it's a dry additive or a liquid additive. So you should always, in a pre-con, have the discussion. If we have a tanker coming out here with 5,000 gallons of material and our valve gets released and all of a sudden 5,000 gallons of that material on the grade, what are we going to do? What's our spill plan, right? Same thing with the dry additive. If you have a pneumatic tanker and one of the hatches on one of the pods opens up and a third of the load of that material is on the ground, how are we going to account for that? What are we going to do? What's the best practice? What's our spill plan? At a pre-con, it's a great time to have that type of conversation. Project selection, just got some do's and don'ts here with that. So generally, FDR process can be utilized anywhere and everywhere, whether it's a rural road to downtown Minneapolis, St. Paul here in Minnesota. So, but you do need to kind of vary your approach as you're working in those different environments. So on a job with water valves, castings, manholes, and curb and gutter, we're generally going to need to go a little bit slower to be more careful with what we're doing. And any of those utilities that are in the way will need to be lowered before the FDR process starts. Right. So the way that reclaimer is designed, it has a lot of power behind it, and it will either destroy whatever's in front of it, or it'll destroy itself. There's no kind of flip gear easy off button. Right? So if we're going to encounter a water main valve, we're just going to obliterate it. That's what's going to happen with that reclaimer. And nobody wants that, right? So you have to be very conscious of what utilities are working in an urban environment. Working next to curb is another animal. We're never going to want to have that drum get in contact with the curb because it's going to damage it. So what an operator will do is they'll get as close to the curb as they are comfortable, and then we'll have a skid steer operator behind us. That skid steer operator whatever that sliver of asphalt is you can't get to. They'll peel that away from the curb, and they'll take those peels of asphalt, throw it back in front of the reclaimer so the reclaimer can size it, and that material will get pushed back in the hole with the blade. So it's really an efficient way to recycle asphalt in an urban environment. Projects with GeoGrid, tensile grid. This stuff is not a good thing to encounter when you're doing FDR. You can see here it balls up in the house in the reclaimer and brings us to a dead stop. So, most of that stuff is designed to, pull itself into tension to keep that surface on top of it from yielding right as you load it up. And so it generally doesn't tear apart very easy. So anytime we have, a tensile grid, GeoGrid, something like that, that big web stuff, that is difficult for us to process. It's difficult for us to get through. There are times when you have that kind of a cheaper alternative, the black, interwoven fabric. That, at times, depending on its age, we can work our way through that and tear our way through that. That also has a tendency to ball up in the reclaimer as well. So those are things that are tough to deal with. Cobble. Some parts of the U.S. encounter this, some parts don't. Cobble, glacial till, whatever you have going on your subgrade, most reclaimers can process any materials kind of softball size or football size. They get bigger than that, and that glacial till will actually tear the reclaimer apart. It'll break off the teeth, the stands, you blow out a planetary. It's not good. So I would say a road with cobble, and it's not necessarily a no-go type situation. What we've done in the past is if we experience a lot of cobble, we'll rake it out of there, with the dozer, and then pick it out with a cobble bucket on the skiddy, and then stabilize that material with the smaller size stuff in there. There are some reclaimers that have drums that are made specifically for pulverizing that type of cobble. Not a lot of contractors have that type of drum in their fleet. So you should expect either way kind of an elevated bid price when you're going to have that type of stuff you road with. So some ideas with the FDR process here to think about as you get more and more familiar with it. Those of you that have done FDR for a while, start thinking about combining additives for superior performance of a stabilized layer. We're seeing this in the cold and pitch recycling world as well. If you had originally planned on doing an engineered emulsion project, injecting about 5% cement or 5% engineered emulsion, try adding 0.5% of cement to that. See how much that improves the performance of what you have going on there. By incorporating multiple stabilization additives gives you a lot more flexibility and will allow you to use FDR in more applications. Partner in FDR with cement, with some cold central plant mix on top and a pavement preservation treatment. It's a great composite pavement you can build. And then always you should be incorporating that robust strength of an FDR stabilized layer into your pavement design to reduce your costs. The idea here is we're going to take our pavement design and we're going to turn it upside down. And we're going to put our money into our base, right? And then we're going to thin up the sections on top to reduce costs for that egg base, and then HMA or some of those higher performance materials on top that get really, really expensive. I think, that's just a different thought process there. So some questions that you always want to have addressed when you're looking at an FDR project. Are the distresses that we're seeing being properly diagnosed and addressed? Have we found all of them, and are they going to be taken care of by the construction process that we selected? Have the existing pavement materials been properly characterized? Right? Have we done an accurate pavement assessment? Project logistics, are those understood by everybody? Right? Are we specifying fly ash on a job where the closest fly ash terminal is 400 miles away? We find something cheaper. Is the material being constructed with top quality recycling agents or additives and workmanship? They always should be. how can you control it? You control it through your specification by specifying exactly what you're looking for on a job and maybe having an experience requirement for your contractors. And you always need to make sure that the current pavement design you're putting together today will meet your expected future traffic expectations. So just tips as it relates to FDR, you want to utilize a modern reclaimer whenever possible, and a modern vein spreader. This is what's going to give you those consistent results, right? You're going to have that calibrated injection pump on the reclaimer and the calibrated vein spreader. And that's what's going to help produce the results you're looking for. You're always going to want to, I can't emphasize enough, compaction, water, density. That is what makes this whole system work, right? You need to ensure you have your stabilized layer being compacted at optimum moisture, right? That's what's going to give you your durability and your long-term strength. It's just key on these projects out in the field. We always want to adhere to your mix times, right? We don't want to break those initial bonds of that material curing out and starting to do its work. We got to get off of it. We never want to stabilize material if it's over optimum. Over optimum, you're not going to get your density, right? So if you have a rain event the night before, you're going to start stabilizing. You might need to wait till noon the following day till things dry down, or maybe even wait a full day till things dry down. The variables you see in the FDR process, cure times for sure. That'll change with the additive you have in there, the material you're stabilizing, and weather conditions. Your rolling pattern can be variable as those in-situ materials might change. You have to keep an eye on subgrade material changes, so you can account for that in your rolling pattern, moisture levels. And also you also want to ensure that you don't ever assume an FDR project will go a certain way. You'll be tricked or lulled into a sense of complacency. No two are ever the same. Another poll question here. Here's see what folks think. What is recommended spacing of field sampling and testing? Great answer there. The answer is E, D, and E. Right, so best practices, maximize the advancement in technology. We've talked about all of these, right? Whether it's from the planning phase to the design phase to the mixed design to QC to the construction technology that's out there. Use all the tools that are available to you, right? And incorporate those into your job. That's what will help you have a successful FDR project. Another idea, hold this flow chart. It's a great tool for engineers from Indiana DOT. Pavement recycling flow chart to give them some guidance on when should I use FDR, when should I use CIR, right? When should I consider mill and fill? Where do they work best? How do they work best? What type of considerations do I need to make? Providing a flow chart for engineers is a great tool. So now we're getting out to those resources. I talked about roadresource.org. It has a ton of information. It will help you out a bunch. It's a great tool and a great thing to get yourself up to speed on. Roadresource.org. Training available. The NHI's 13-10-50 course is available as well. And then on ARA's website, there are a bunch of guideline specifications on the website. Just go to arra.org and search guidelines, and all of these will come up. All right, there's guidelines for bituminous stabilization with FDR, cementitious stabilization with FDR, line stabilization with FDR. There's best practice construction guides, there's quality control sampling guides, testing guidelines. Many great resources are there and available for free on the website. some additional resources for specifications, right? Astro has some of those. Like I mentioned, ARRA at arra.org, you can find those. And then many states have construction specifications that they're successfully implementing today. So reach out to your network to some of those folks and see what's working for them and get some eyes on them. And there's lots of research going on currently in regards to FDR, cold mix, and these types of materials and recycling through the NCHRP process. That 9-62, they have a rapid test that they're bringing out to know when that material is cleared out, the short pin and long pin test. That's pretty interesting what they're working on there. There is a lot of research currently ongoing at both NCAT and the NRRA at those test sections up at Midroad. Virginia DOT is doing a lot of great work as well. You can follow up with. Do have some helpful links here for folks to find more information. The FHWA, right, they have a checklist series. Great source of information. Again, ARRA, and then roadresource.org. The Pavement Preservation and Recycling Alliance have put together a lot of information on FDR. And the barn. It's an oldie but a goodie. It's steady, and it's a great resource. So it's the Basic Asphalt Recycling Manual. So it was originally published in 2001. It got a refresh in 2015, and these are actually really easy to get a hold of. All you have to do is go to ARRA's website, find a contractor member that's local or close to you geographically, reach out to them, and they'll get you a copy of the barn if you're interested. And final thoughts, right? We have kind of keep hammering on all these, but in conclusion, we want to make sure we're utilizing the right tool on the right road at the right time. That's what makes FDR a success or not, right? Finding that slot where it works best in and applying it there. When you do that, you're going to save money, save time, and you're going to be doing the sustainable thing of reducing carbon emissions and then recycling and reusing your materials. I'm going to hand it back over to Jason.
Yeah, I'm going to turn it over to Ann.
Thanks, Jason. Thanks, Jason. Again, thank you everyone for joining us today, and thank you especially to both Dan and Jason for working and putting together today's presentation. Our next webinar is scheduled for January 14th at 2 p.m. Eastern Time, and that will focus on life cycle assessment, product category rules, and environmental product declarations. You can register at the link provided on the slide, or you can visit roadresource.org for more information. Again, thank you everyone for joining us today, and with that, I'll pass it back over to you, Jason.
Thank you, Ann. So Dan, here's your contact information for anybody out there that's wanting further information. Dan would be happy to help out. With that said, we got about 8 minutes. Let's see if we can tackle a few of these comments here, Dan, and then I'll throw it into evaluations.
Okay, sounds good.
Move up here. A lot of good questions. And if we don't get a chance to answer all of them, when we send out the PDHs and the site for the webinar, we'll include some of these comments that we didn't get a chance to answer. I believe I answered a few of them on the coefficients. I recommend the barn for Greg. But that answers some of those questions. Looks like a lot of other folks kind of threw in some answers to them too. So here's from James Anderson, Dan. Mill and stockpile wrap, FDR with cement, along with CCPR as a sustainable pavement reconstruction. This approach provides a huge cost savings as well as faster construction and less impact to the public. And thanks for that key, James. I appreciate that. Here's one.
Yeah, that's a great way. Go ahead, Jason. Sorry.
Here's one from Nick. Does M use, I'm not sure M use CCP testing rather than compressive strengths or ITS?
Is the
I'm
question
not sure if that's in Mexico or New Mexico.
what's the question? What would be preferred?
I'm not sure. Yeah, I'm not sure if Dan will answer that question or not. Or not Dan, but I'm sorry, Jeff Mann. Jeff Mann might have answered that.
Yeah, I mean, the DCP is used out in the field, right? Those in compression type tests are done in the lab. So, I'm not sure what the question is there exactly.
Here's a better one, Dan. Would DCP information on the existing base granular material be useful to contractors as part of a tender package?
It definitely would be helpful, especially if it'll tell you what the condition of that base is, right? And any type of information you provide in regards to that would be helpful, especially if if the contractor is the one controlling the mix design, or the one that needs to provide the owner with the mix design, that information would be very helpful.
Here's another one. We got a design engineer that's fairly new. When grinding the existing roadway and replacing, does the process just provide a new base that still needs to be resurfaced?
Yes, it does. Yep. So the asphalt pulverization process will provide a base that still needs to be surfaced. Yep.
And then following up on that question, is that if that's the case, does the process raise the elevation of the roadway?
Yes, it would. Yep. So you might see a little bit of material growth depending on what the depth of that HMA layer is, the old layer. Very minimal, but yeah, whatever surfacing you would put on top of it would increase the elevation. If you have elevation limits on a project that you can't feed, there's many times we'll go out and we'll pre-mill that old asphalt surface first. So you want to put 2 inches lift of asphalt back out there. We'll mill down 2 inches, remove that material, do FDR on the remaining HMA, recycle it, pulverize it, and then lay it back and match those grades back right to where they were.
All right, Dan. Here's a question. Any studies on how deep compaction can be met with FDR foam?
I don't know of specific studies, but have experience with going to depths as deep as 10 inches. We haven't done a 10-inch job ourselves yet, but if you have the right action equipment, I wouldn't have any issues going 12 inches. I think the issue you might run into at that point, 12 inches, it's a lot of oil, and it's a lot of material to mix and get through the housing, and so the process is going to go slow.
Thanks, Dan. Got about a minute left, and I want to take the time to please, if everybody could, the file share pod there, as you see, you can download the presentation for today, and I'll keep it up for I'll keep this site up for the next 15, 20 minutes. And I really please would request that everybody take the time to go through the evaluations. It's very simple. Use a little small arrow with a line to the right underneath the arrow, and go through that and give us your feedback, because as we do these webinars, and we have been since February, we really appreciate the comments that we get, and they're very useful as we go on to this next year to evaluate further webinars. So take the time to do that. We greatly appreciate it. With that said, Dan, I'd like to give you the floor for any remaining questions or any things you'd like to say.
I just want to thank you for the opportunity to present today, and encourage folks to check out roadresource.org. It is a great tool and has a lot of great information.
Thank you, Dan. And with that said, that kind of wraps up our presentation for today. And appreciate everybody taking their time to participate. And if you have any questions, feel free to reach out to either Dan or myself. and we wish everybody a happy holiday.
Thank you. That concludes our conference for today. Thank you for your participation and for using AT&T teleconference service. You may now disconnect.
And Dan, if you're still on board, same.